Let's now discuss the very first design for our weather station problem. This is the design diagram for the very first design, and I would suggest that you pause the video and do the following two optional exercises. Number one, just by inspecting the design diagram, which we talked about its syntax previously in the lecture, is it possible for you to actually imagine how everything is going to work without looking at the code? And exercise number two, given a diagram, if you were to implement this particular design, how would you do it? How would you declare the attributes based on the client-supplier relations? And how would you define the routines based on the comments that we gave to you over here? Think about these things informally, or even sketch in your mind would be valuable exercises for you to do before you move on. Okay, so assuming that you have done the optional exercises, maybe, so let's now talk about the essence for this particular design. So whenever the display feature is called, we have to retrieve the current values of temperature, humidity, and pressure via the weather data reference. Remember, we said that every app has their selective set of features or selective set of measures they're interested in. For example, the forecast app is only interested in the pressure data, whereas it doesn't really care about the temperature or humidity, right? So that's just one example. So now we're going to see exactly how the static architecture as outlined over here is going to work, and then we talk about runtime as well. Okay, this is the design diagram. Let's now talk about side by side. So here we don't really separate the server and the clients into different clusters, but potentially you can do it. On the one side, you can have one cluster for just the server over here, the blue one. So let me just write it down. So it would be the server over here. And on the other side, we also got the multiple clients. In general, you can have as many clients as you wish, as many different clients, as many different kinds of clients as you wish over here. So here, this would be the clients. Okay, you can see kind number one, kind number two, and kind number three. Let's look at the server to start with. You can see for the server side here, we got temperature, and we got humidity, and we got pressure. So these are the three pieces of weather data that any potential app might be interested in. And also, in order to really define the validity constraints for the weather data, we have to make sure whenever you create a weather data instance, what does it really mean for a weather data to be valid? So it'd be very important. So correct limits is really a function that we're going to say will simply take the current value for temperature, humidity, and pressure, and then we had to constrain the range of values for each one of them. For example, temperature should really normally between maybe minus 50 until maybe plus 50, for example, right? There's got to be some constraint on the valid values for each measure. And this correct limits is a helper routine, helper query that is going to define such limits. When I show you the implementation, you will see some example over there, right? So you can see the most important message from the server side is, number one, we got a different measure over here. And number two, you have to make sure you define the validity constraints to say, whenever you create a weather data objects, what does it really mean for that particular object to be valid? In which case, we have to use class invariants. So remember, before we introduced to you the idea about design pattern, we really emphasize about design by contracts. So having contracts, especially class invariants, will be very important in the context of object-oriented design. Okay. So that'll be from the server side. What about the client side? You can see that for every client, we actually got a client-supplier relation, right? You can see they have the common kind of a supplier. And the supplier name, for convenience, is simply called weather data, meaning that in the forecast, in the current conditions, and also in statistics, for each one of them, there should be an attribute of type or variable declared of type weather data over here. So that'll be the supplier name, right? So you have to really recall all the syntax that you learned from the previous diagram. You can think about the weather data over here is the name of supplier. Whereas the weather data over here is the kind of supplier, or the type. Kind or type of the supplier. Okay, let's look at the individual clients, and then you will see the pattern that we are trying to show you over here. Let's say for the first one, for the forecast, we know that the forecast is only worry about the pressure. So you can see we're trying to maintain what's the current pressure and what's the last pressure that we got updated. So now if you compare these two, if you go from the last pressure to the current pressure, if somehow it's really reducing, in that case we know it's actually more it's likely to rain, right? That's kind of the idea. And then you can see for every clients, you will have the display feature or routine over here. So that means periodically, either the app itself or somebody has to make sure they update the display. And then we'll talk more about the display later. And also for the current condition, it's just another app. So it also got the display function over here. And then for the current conditions, it actually cares about two measures as we spoke about the temperature in Celsius and also the humidity in percentages, right? That's what we talked about before. And finally, we got a third app, statistics over here, which only cares about temperature, about its minimum, maximum, and also average so far. And in that case, we also got display. Okay, so now I'll recap about the client side. For every client, we have to define the display routine over here, which I will speak about. Basically, for the display, you're going to retrieve and also display the latest data. But how do we get the latest data? We have to follow through this particular client-supply relation to say every forecast, every current condition, and every statistics objects at runtime, they are linked to some kind of weather data objects. So that every time if they want to get the most up-to-date measure about, for example, temperature, they have to go through this particular relation over here. So statically, we are showing this client-supply relation as an arrow, right? That's about a compile time property over here. But at the runtime, the weather data is going to be a link to some supplier objects. So this is something I'll show you later. Okay, so that's about the static architecture for this design. So let's now take a look at some code. Some implementation. So if we go back to the slides, you can see that. So now we'll talk about the various classes for the first design. For each of the designs that we talk about in this lecture, we made available to you. It's a source code, so we might omit some irrelevant details for our discussion about design in the slides, but you can definitely find the complete details in the source code. The first class we want to talk about will be the server, the weather data. So here we got the three measures, temperature, humidity, and pressure of type real. So real is like the double type in Java or in C#. And then we got one query over here, correct limits. So this is the routine that we're going to use for defining the class invariants. So we are saying, for example, the pressure over here, P, should be between 50 and 110. So these are simply just a magic number. You don't have to worry too much about them. But I think the main point is, every time you want to have attributes for your class, always think about what would be the validity constraints for the attributes when you create the objects for that particular class. In which case, you have to define the class invariants properly. And for the constructor over here, we got precondition. We want to make sure, notice that the make may either be used as a command or it might be used as a constructor. So these are the two usages that we spoke about in the previous tutorial or lecture. So we are saying that whenever you want to make a change or you want to make a new object of type weather data, you want to make sure the T, temperature, P, pressure, and also H, humidity, all these values must be valid. Otherwise, you are either going to create some invalid weather data objects, or you're simply just going to have a resulting weather data object that's simply invalid. And the post condition will be very straightforward. You simply want to say the temperature has been set to the input T, for example. And the class invariant over here is quite obvious. You simply just have to call this particular routine that we define over here, and then you want to make sure the current temperature, pressure, and also humidity really satisfy all the constraints that we talk about over here. Let me explain a little bit further one common confusion. You might be wondering why we are repeating this particular call to the correct limits twice. One, in the context of the precondition for the constructor or the command. And number two, in the context of the class invariant over here. Think about the logic over here. what we start with is we want to make sure the invariance for the class is first defined. Think about this happens first. So for every weather data object, we want to make sure this particular Boolean condition is always satisfied. That's number one. Accordingly, we want to make sure any updates to these three measures about temperature, pressure, and humidity, the updates should not result in a weather data object that's actually failed to satisfy such constraint. So this is why so for the make this for now, this is the only command or constructor that is going to change the temperature, pressure, and humidity. That is why we want to have a precondition over here to make sure any clients passing the argument values for these three measures, they must give valid values. Otherwise, you're going to result in a class invariant violation, which is really the worst thing that you want to have, right? That's all about the design by contract discussion that we had in the previous part of the course. You can definitely review them if necessary. Okay, let's now talk about the three different client classes, and they have very similar structure, especially how they display. You always have to update before you can display. So for the forecast app, so we have we only worry about the pressure. So we want to keep maintain what's the current pressure and what's the last value we read for the pressure, right? So we can decide if you go from the last pressure to current pressure, if it decreases, in that case, you know it's likely to rain, for example. And for every app class, we also got this weather data supplier. And then you can see that the type of supplier is simply weather data. At the runtime, this is going to be a link to the supplier objects, but I'll visualize how things work at the runtime in a moment. For the constructor over here, we'll simply just initialize the weather data to be WD, right? You can think about whenever we initialize the client objects of various types, we always try to have aliasing, which means every one of them is going to point to the same server for the weather data. Well, we'll see that. Okay, now for the updates, update would be application-specific operation depending on what weather measures you're really interested in for this particular weather app. So now for the forecast app, we are interested in the pressure. So that's why you'll see the current pressure is simply assigned to, will simply link to the weather data at the runtime and then get its pressure, the latest read. And for the display, always, if you want to display the latest value, you have to update first. You can think about we always have to call the updates over here, which is application specific, in order to really display for this particular app. Okay, for the remaining two application classes that we're going to discuss, you can think about they always got updates over here. Okay, and then we say, okay, so the remaining part will just be conceivable, right? For example, you will see that if somehow the current pressure is larger than the last pressure, that means the pressure is increasing, in which case we can say, well, improving weather on the way, for example. Okay, the second application class is the current conditions, which only worries about the temperature and humidity, right? It does not worry about pressure. So whenever we want to update the current conditions, we do not have to worry about the pressure value. So weather data, again, so this will be the supplier, right? Of the same supply type, weather data. And then for the constructor, we'll simply assign weather data to the WD, the input argument over here. Presumably, it will be the single supplier, the single server object that we are trying to assign to every client objects. So for the updates, so now what should we update? Well, we should really update temperature and humidity. So that's why you will see we should really update the temperature and humidity by following through the link for the weather data to their temperature and humidity, the latest measure, the latest reads for these measures. And then for display, what should we do? Well, as always, for every app, even though the display contents might be different, but the first step is always the same. You have to updates to the latest measure for whatever measures you're interested in. And then once you update, so now you can display the temperature and also humidity accordingly, right? That'll be quite easy. Finally, we got statistics app. And for that one there, we only worry about the temperature. So that's why we declare current temperature. But programmatically, we also need to calculate the maximum, minimum, and also the average. So that's why we're declaring these two attributes over here. The number of readings simply just will allow us to really calculate the average, and also the summation so far for the temperature. If you divide this number here by the number of readings, you will get the average, right? It's very simple programmatically. And then also we got weather data here as a common supplier, right? And now for the for the constructor, well, as usual, we'll simply assign weather data to be WD. You might notice some common pattern among these three kinds of application classes. So one improvement for the design might be you can simply create a new common superclass, simply call that weather clients, in which case you can factor out any common code. For example, you can see there's always a common supplier called weather data. You can put it in a common superclass. So it will be inherited verbatim into each of the client classes for reusability. And also you can see the constructor is always the same. You can also minimize the code duplicates by putting the constructor in the parent class as well. I'll leave that design improvement to you. But for us, we're just going to stick to these versions over here. And then for the updates, since we only worry about the temperature, so we just say the current temperature is simply following through the weather data link to the temperature. Okay, and then of course we also have to update the minimum, maximum if necessary. You can see the details for the implementation in the source code. We're just omitting that just to focus our discussion more on the design. And for the display, also the first step is always update. You can also potentially put this common first step in the parent class if you want to move on to the better design optionally. Okay, after the updates, we're just going to print out all the measures for minimum, maximum, and average. So that's about a very quick walkthrough for all the implementation detail that's necessary for you to understand what's going on at the compile time. And next step will be, let's see a very simple test to see how we can test all these 4 classes, 1 server, and also 3 clients at a runtime. Let's see how we can do it, and we'll visualize what's going on. Okay, so this is a very quick reminder about the, you can think about these 2 slides on the iPad are actually essentially talking about the same information, except that in this one over here, we're just trying to replace every class over here with some informally detailed view. Over here, right, you can see the forecast. We are simply just showing to you how the forecast has been implemented as we showed to you, right? You can really compare these 2 diagrams side by side for your understanding, right? But when you submit your design diagram for any purpose for this design pattern, you have to make sure you really follow the proper syntax for the bound diagram. Okay, so this one here, I just want to point out a few things that I already discussed quickly, especially for the application. For each of the application, you can see that we got the display over here. You can see display over here, and also display over here. For all the for each kind of the 3 apps, for each one of them, for the display, the first step is always updates, and also updates. So this is a common first step for every application, right? Every time you want to display, you should update first. And then for the updates, it will be application specific. For example, you can see for the updates over here, let's say for the updates for forecast, you have to update the pressure. And for current conditions, for the update, you have to update temperature and humidity. And for statistics, in order to update, you have to update the temperature. And now, in order to update, you have to really make a link to the weather data supplier objects at the runtime, weather data, and also the weather data, right? So that's the thing I want to review very quickly together with you before I visualize what's going to happen at the runtime. All right, so let's now switch to the next page. This will be the test, as actually you can see on the slides. I also include all the necessary code that we might need to look at over here. Okay, I already spoke about them. So this will be the runtime object diagram. I just did some starter diagrams so that we can save some time when we do the illustration. And this will be the actual test that I'm going to go through. Let's go through line by line very carefully. So now let's see this. We'll simply just go for weather station. Let's see what are the declarations. So we got CC of type current conditions. We got FD of type forecast. We got SD of type statistics. So these are the 3 application objects. And we have a single server WD of type weather data, right? So these are the 3 things we have to, so these are the 4 variables that we have to worry about at the runtime. Let's try to do this gradually. So let's say the first line over here, when we say creates WD.make, so that's a weather data. So we want basically the temperature pressure and humidity. So these are the values. So we'll simply set up WD over here. You can see WD is already here. And now we're going to set to be 9 for temperature, maybe 75 for the pressure, and also 25 for the humidity. Right? It's very easy to set up the server. So now let's now also set up the individual application. So for example, let's see the first one. Let's say for current conditions. So for CC, the current condition, you can see we already got this particular object over here. So now WD, think about what's going to happen here. So if you look at the current conditions in the definition over there for current conditions, so now the WD over here is simply just going to be the WD. And the WD is really referring to this WD server objects, right? So let's just do one, and then you will see exactly how that works. So what we'll do is we're going to say whatever the weather data attributes is now going to point to WD. It's actually aliasing, right? Remember, weather data is simply the attributes over here. So now what's going to happen is for CC, the weather data attributes over here is now going to point to this particular WD server. Okay, so that's the first one. So what about the forecast, for example? So now for the forecast, you can see we say creates fd.make, and now it's going to call the constructor, which is completely identical. So now if you go to forecast over here, the make is also going to set the weather data to be whatever the WD is. So here is a little bit typo. So this should just be WD over here. Okay. So now how's it going to work? So now for the weather data, it's simply just going to point to WD. Just the same. So you now can see the forecast and current condition apps are pointing to the same server objects. Finally, so what about when we say creates sd.make WD? Well, similarly, you will also go to statistics over here, and then we're going to call this constructor over here. So again, this will be WD. Okay, whatever WD you pass as arguments, you're just going to assign that to the weather data attributes over here. So now for the weather data, so now for the statistics app, so weather data is also going to point to the same weather data. So now you can see we got 3 aliases for the weather data over here, right? So you can see we got all 3 of them are really pointing to the same weather data objects. That's really important to note. So every time when we want to update each one of them, either one of them, you're just going to get the same latest measure. Okay, so now let's talk about exactly how we can simulate the updates for the app for several display. Let's now take a look. So now let's say, first of all, we say wd.set measurements. Okay, that's one of the commands that we define. So now we're going to set to be 15, 60, and 30.4, right? So it's going to be 15 and also 60 and also 30.4. So that's just an update. So now that means every time for the forecast to really for the forecast for current condition and for the statistics, in order for them to really calculate and measure, they should really do updates. So now, for example, if you say cc.display, and just talk about one by one. If you try to say cc.display, you're really saying cc is over here, right? If you go to current conditions, their display, as I mentioned before, they should always do an updates first. And for the updates, you have to go to the weather data and then try to update the temperature and humidity. So that means you're going to follow through this particular link and go to check to see what's the go through this link. You're going to see what's the temperature and what is the humidity. So these are the 2 data you will need, right? Right. That's about the cc.display. And let's now do something very similar. What about the forecast? If you say fd.display, fd is referring to forecast. Now, if you go to the forecast over here, you can see display also needs to call updates first. And the update is simply just going to update the pressure. So that means what's going to happen is the forecast is also going to link to the same weather data and then see what the pressure is. Okay, and then similarly also for sd.display, right? So I don't need to repeat that information there. So sd.display, you also just try to link to the same weather data objects and see what the temperature what the temperature is for the statistics app. Okay, so that's about every time you want to call the display for the app, you have to follow through the link that's really linked to its attribute metadata. Let's say we have done this, but what if, let's say maybe a few seconds later, let's say because we said periodically, right? Let's say for every 2 seconds or for every 1 second, your app is going to update itself, is going to display or refresh the display. So now if you say CC the display again, so now you can see that in between these two, it's really important to note, in between these two, let me do a separator over here. In between these two lines, okay, you can see there's no change on the WD, right? You can see after set a measurement to be 15, 60, and 30.4, and we do the display. That's all good. However, there was no change after that particular set measurement, but we are trying to display it again. In that case, you can see in order for CC the display to work, you have to again try to say CC, which is current condition. You're going to still actually link to the weather data, and then you're going to find out what the temperature and also what the humidities are. You got to do the same process again, the same kind of computation. Similarly for forecast and similarly for statistics, in order for you to finish these 3 calls over here. To finish the illustration, let's say we go to WD, the set measurements. In this case, we're going to change maybe from into 11, 90, and 20. So it's going to be 11, and then to 90, and then to 20, basically, right? So now after this, you're again going to follow through 1, 2, and 3. And for each one of them, you're just going to follow the link to the weather data, and also weather data. Okay, so that's about the how this particular first design will work at a runtime. Okay, hopefully at least you know how it works by this little test. Let me just go back to the slides. So that's exactly what we just illustrated. Okay, so now we want to know if there's any limitation or drawback for this first design. Okay, so now you can end the video and think about what the drawback might be based on the runtime illustration I spoke to you about. I already gave you some hints about in the test. Think about it before you move on to the next video.